Okay, we're going to continue our work with elimination, and we're going to now look at situations where we need to multiply before we eliminate. So sometimes you need to multiply one or both equations by a value to use elimination. So you can see that if I line up these equations, remember our line up like variables for elimination, you can see that there are no variables that have the same coefficient. However, look at the x's and look at the y's. When I look at these y variables, I can see that if I can multiply the bottom by -2, I'll be able to subtract. So I'm going to multiply the entire bottom equation by -2. And I'll get -10x minus 4y equals 8. Remember, when we multiply, we have to distribute to every piece. Now I can add my equations. -7x equals 14 and x equals -2. I can continue my elimination process using either of my original equations. I'll go ahead and use this one. 5x plus 2y equals -4. So substituting my x value, I'll get -10 plus 2y equals -4, 2y equals 6, and y equals 3. So my solution is -2, 3. Now I want to show you why this method works best when we have all different coefficients. If I tried to use substitution, and I'm just going to do a little bit of it, I would have to solve one of these equations for one variable. None of them already have a coefficient of 1. So I'm going to try to solve, I'll try to solve this equation for y. So moving the 5x to the other side, dividing everything by 2. So our y equals -5/2 x minus 2. Now I've got to substitute this into my other equation. So I have to multiply 4 times -5/2 x minus 2 equals 6. And you can see that I'm having to use fractions all the way through. Whereas in this method, I didn't have to use fractions at all. So generally speaking, when the coefficients of my variables are not nice even ones or opposites of each other, it's still best to use elimination. Alright, try this one on your own. Again, you're going to have to multiply one or the other equations by a number. Okay, now you might have run into trouble with this, so let's see what's happening here. So 2x minus 3y equals 6. Alright, I can't multiply 2 by anything to get 3 or vice versa, and the same thing with the y's. So I'm going to have to multiply both equations. So I'm going to take the x's because the numbers are just a little bit smaller, and I'm going to think to myself, what is the common factor of 3 and 2? So it's going to be 6. So if I multiply the top by 2 and the bottom by 3, both of those coefficients will be 6. I'm going to take it a step further and multiply the bottom by -3. So now 6x plus 8y equals -50. On the bottom, I'm going to get -6x plus 9y equals -18. Now I can add these up. 17y equals 68, -68, and y equals -4. Using my substitution to finish this off, I'm going to go ahead and use the first equation. 3x plus 4 times -4 equals -25. 3x minus 16. Adding 16 to both sides, x equals -3. So my ordered pair is -3, -4. So this time I had to multiply both equations in order to get opposite coefficients for one of my variables. Alright, got a word problem now. This is a little tougher than the one we did in the last video. A bakery is making peanut butter cookies and loaves of quick bread. The management has allotted 800 minutes of employee time and 900 minutes of oven time. If the cookies require 20 minutes of preparation, so that's employees, and 10 minutes of baking, that's the oven, and the quick bread requires 10 minutes of preparation and 30 minutes in the oven, write two equations that would determine how many of each type of item the bakery should prepare. So how many of each type? Those are my variables. So I'm going to use P for peanut butter cookies and Q for quick bread. So for my peanut butter cookies, I need 20 minutes of employee time and 10 minutes of baking. But I know my total time for the employees. So if I could add up the peanut butter employee time and the quick bread employee time, I know the total there. So 20 minutes for the peanut butter cookies plus, let me see, the bread needs 10 minutes for the quick bread. That should equal 800 minutes of employee time. Now let's look at the oven time. For the cookies, I need 10 minutes in the oven. And for the quick bread, I need 30 minutes in the oven, and that should total 900 minutes. So now I can use my elimination. I'm going to multiply the bottom equation by -2. That way my p's will cancel. Top equation stays the same. Bottom equation is getting multiplied by -2. And so those cancel. -50Q equals -1000. So Q equals 20. So 20 batches of quick bread. Bring that over. I'm going to bring my top equation down. 20P plus 10 times 20 equals 800. 20P plus 200 equals 800. 20P equals 600, and P equals 30. So 30 batches of cookies, 20 batches of quick bread, and that should work out perfectly. Alright, so let's recap our methods for solving a system. The first thing we did way back in the first section was graphing. We know that this isn't always accurate. It uses an algebraic solution. We should use an algebraic solution for an accurate point, not a graphing. So don't use graphing unless you're specifically told to do so. Let's also think about this last one. To put this on a sheet of graph paper, we'd have to use a very big scale, and we're definitely not going to get an accurate answer. Okay, so graphing, not always accurate. Use an algebraic method unless you're specifically told to do a graphing one. Algebraic methods, we have two of them. Substitution, you set the equations side by side. This works best if one of the variables has a coefficient of 1 because then it's really easy to isolate the variable. Elimination, line up like variables. This works best if one set of like variables has coefficients that are the same or opposites, but it's the best method to use if your solutions are not integers. In other words, if you start to do substitution and you get fractions, go back to elimination. Okay, I'm going to put one more example. Choose any algebraic method, substitution or elimination, and solve. Pause the video and come back. Okay, I'm going to do it both ways. First way I'm going to use is elimination. So I'm going to bring this x over to this side, and I'm going to line up my variables. I'm going to multiply my top equation by -4. -4x minus 8y equals -56. 4x minus 3y equals 12. I'm going to add these up. -11y equals -44. Y equals 4. Go back to my substitution. I'm going to go back to this original equation. 2y equals -x, -4 plus 14. 2y equals 10, y equals 5. Oops, how did I get x and y the same? hold on, I substituted that into the wrong place, didn't I? Okay, y is 4, so 2 times 4 equals negative x plus 14. 8 equals negative x plus 14. Subtract 14, I get negative 6 equals negative x equals 6. That's better. All right, let's try substitution. 2y equals negative x plus 14 and 4x minus 3y equals 12. I've set them up side by side. I'm going to add the x to this side and subtract the 2y to isolate my x. I'm now going to use my substitution by bringing this over and putting it in place of x. Distributing, negative 8y minus 28 minus 3y equals 12. Negative 11y, adding 28 to that side. I get 30. Something has gone wrong. Alright, let me try it again. 2y equals negative x plus 14. If I add x to that side and subtract 2y, did I copy these right? 4x minus 3y. Okay. So substitute in negative 8y. Oh, 4 times 14. There's my mistake. I hope somebody caught that. So 4 times 14 is 1656. So now I can combine those, and if I subtract 56 from both sides, I get negative 44. Y equals 4. Substituting it back over into this equation, 2 times 4 equals negative x plus 14. You can see I'm doing the same work I did at the end of the other problem. So 8 equals negative x plus 14. Negative x equals negative 6, and x equals 6. So again, elimination on this side, substitution on this side, and that's it for the video.